Hi guys, we are going to go ahead and read through our scientific variables notes. An independent variable is the part of the experiment that is manipulated or changed in order to test the hypothesis. So we're going to go ahead and highlight that. The independent variable is one that is manipulated or changed, and it is purposely changed. Purposely changed by the scientist. So examples are the type of paper towels in experiment to determine which absorbs more, the amount of sugar given to baby mice when trying to determine if sugar affects weight gain, the type of ice cream when you want to know which will melt the slowest. So the dependent variable is the part of the experiment that changes in a measurable way in response to what is being tested. So that's the results. So the independent variable is the one that's measured. It's the results. It is measured. So when we had the independent variable of the type of paper towel to determine which one absorbs the most, what we are going to do for the dependent variable would be the amount of liquid each paper towel picked up. So the first one here with the amount of sugar given to mice, what we're measuring would be the weight gain of each mouse. When we had the different types of ice cream and which one would melt the slowest, what we're measuring would be time each ice cream took to melt. So the constant, it's going to be everything else in that experiment so that we know what actually affected the results. So the constants in an experiment are the parts that stay the same to make it valid. Okay, stays the same to make it valid. So in this example with the paper towels, what's going to have to stay the same is the size of the paper towel, the amount of water used, the container the water is in, the type of water, whether it be distilled water or tap water. Everything has to stay the same. The only thing that is different is the type of paper towel, the brand of paper towel. What for the mice, you have to have the same size of the original mice, the same amount of activity. Where the mice live, they have to be living in being exposed to the same elements. Everything's the same, except for the amount of sugar that they're going to get. So then with the ice cream, what has to stay the same is the amount of each type of ice cream. So is it, 1 scoop? And even more specific, you would want to put that on a triple beam balance and figure out the mass. Make sure it's the same amount, has the same mass. The temperature in the room. Can't have one really, really cold and then one really hot. Because of course the one that's really hot is going to melt a lot quicker. The size of the bowl that the ice cream is in. All of those things are going to affect how quickly or how slowly, in this case, the ice cream melts. Okay. So what we're going to do is we're going to take a look at a few scenarios. So in the experiments described below, underlined the independent variable. So the one thing that we are purposely changing. Whoops. So that's the IV. And we're going to circle the dependent variable. That's the DV. Then list the controls needed to keep the experiment valid on the line given. All right, so here is our testable question. How does the amount of acid in the water affect the length of the lives of the fish in the water? Okay, so what are we purposely changing? So we're purposely changing the amount of acid in the water. So then what are we measuring? So the length of the lives of the fish is what we are going to measure. So when we increase the acid, the scientists would determine how many days or how many hours the fish survive. All right, so what has to stay the same? So we have to have the same amount of water. and that would be the same amount of water in the tank, because that would affect the concentration. We have to have the same type of fish. We have to have the same number of fish. And we would have to have the same type of acid. Because what we were purposely changing would be this amount of that acid. So you have to have the same type of acid that you are adding to these fish tank. All right, so let's take a look at the next one. How does the amount of baking soda, I'm going to change my color here just so that we can, it's getting a little crowded here. So how does the amount of baking soda used affect the size of the cookie baked? All right, so what are we purposely changing? We're purposely changing the amount of baking soda. And what are we then measuring would be the size of the cookie. Okay, so what has to stay the same? It needs to be the same recipe. So if you're making a chocolate chip cookie, for example, you have to use the same recipe, but then just vary the amount of baking soda. We need to have the same scoop. So you have to put the same amount of cookie on the cookie sheet when you are baking them, because if you put a whole bunch of cookie dough, as you know if you've made cookies, if you put a big scoop of cookie dough on your cookie sheet, you're going to get a really big cookie, not because of the baking soda, but by the amount of dough put on the cookie sheet, right? Okay, so we need to have the same cookie sheet. So does the cookie sheet affect at all, the size that the cookie can get? We need to have the same oven temperature. And we need to have them cook the same amount of time. So everything is going to stay the same. We're going to have the same recipe. We're going to put the same amount of cookie dough on the cookie sheet. We're going to use the same cookie sheet. We're going to use the same oven temperature. We're going to use the same oven. We're going to cook it in the same amount of time. But the only thing that's changing is the amount of baking soda that's added to that recipe. And does that affect the size of the cookie? All right, let's change again, and let's do the next one. How does the shape of a skateboard affect how fast it will travel? All right, what are we purposely changing? We are purposely changing the shape of the skateboard. What we are measuring is how fast it's going to travel. So what has to stay the same? We need to have the same material that the skateboard is made out of, okay? Because we can't change the type of material that it's made out of, and then also the shape of the skateboard, because we're not going to know, well, which one was it? Was it the shape or was it the material? So you can only isolate one variable at a time. So you have to have the same material. We need to have the same rider, so that rider has the same push-off and the same technique in riding that skateboard. You need to have the same riding location. So you need to be doing the same course on the skateboard park or a half pike or whatever it is. You have to have the same location, because otherwise you've changed that variable. You need to have the same push-off. So that falls in also with the idea of using the same rider. And so the same push-off to start. Are we adding more or less force when we push off? Well, that's going to affect how fast the rider is able to go, okay, how fast they will travel. All right, so everything's the same. Everything about this experiment is the same. The same rider, the same location, the same technique, the same material that the skateboard is. The only thing that they're changing is, all right, what is the shape of that skateboard? Okay, so we have to have the same wheels. So all the mechanisms with that skateboard, and I don't know anything about skateboard, but the wheels and the bearings and that type of thing, that also has to be the exact same thing. The only thing that's changed is the shape. Okay? All right. One last color change. What should we choose? Let's choose green. Oh, we've already choose green. Let's choose blue. There we go. Okay, so how does the size of a bicycle tire affect the distance it will travel when it is pedaled a certain amount of time? All right, so what are we purposely changing is the size of the bicycle tire. So do we have a bicycle tire that big? Or do we have a bicycle tire that big? Okay. All right. What are we measuring? Will be the distance traveled. Okay. So when it is pedaled a certain amount of time. So we have to have the same bike. We would just simply change out that tire. We would need to be at the same location. Okay, you know, we can't have one on flat and then the next one on a hill going down or a hill pedaling up. Okay, you have to have the same location. You have to pedal the same amount of pedal times. Okay, so if you are going to say, all right, I want you to pedal 5 times. 1, 2, 3, 4, 5. Stop. And let's measure that distance with this tire. And then 1, 2, 3, 4, 5 with this one. And measure the distance with that larger tire. So that's what I mean by the same amount of pedal times. Whatever it is that you've determined is going to be the number of times. That could be 10 times. It could be 20 times, okay? Because when the question asks when pedaled a certain amount of time. So that's kind of up to interpretation as far as what is that certain number of times. Well, that has to be determined by the scientist. And as long as you do the same amount of times for both trials or 3 trials, it's fine, okay? So you have to have the tires have to be inflated the same, because we know that riding on a flat tire is not going to be as effective as one that is to the PSI that's supposed to be. Okay, so you also need to have the same rider. So because that rider will be able to reproduce the force that they're putting on the pedals, whether they're standing up, whether they're sitting down. So that rider technique is what we're going to call that. It's got to be the same. Are you sitting down the whole time? Then sit down the whole time. If you're standing up the whole time, then you're standing up the whole time, okay? All right, so that is a little bit about being able to identify the independent and dependent and then control variables, but keeping in mind that you can only purposely change one of the variables, okay? Because if not, you do not know which variable you can give credit to for the results. So the independent variable is the one that you are purposely changing. The dependent variable is the one that you are measuring. The control variables is everything else that stays the same between the two groups, okay? All right.